So Gene was with Texas Instruments and retired as their principal fellow. He is very interested, and he'll say it himself, in like starting projects, and then once it's going, he like leaves it and jumps to another. And so he was very innovative. He would always tell students like just to like he would tell them, just start, just try, and be their encourager. And it's awesome to see that he applied that to himself as well. He holds 48 patents in the areas of speech and consumer products and DSP. And he's a fellow of IEEE, and he's currently the co-founder of Octavo Systems. I don't know if he'll be on the call today, but he might join. I know Sandra Disner, who's our next presenter, is on the call. So if we want to have her, if she's willing, we can ask if she wants to take questions. I'll ask her for that after we play her video. But first we have Gene Franz, so let's give him a round of applause. Hi, Gene. I'm Natalie. I'm an engineer at Gridspace, and I've been helping run this series this year. So you started working at TI. What was it like at the start, and where did it go?
Well, I was hired into what was known as the calculator division.
Hmm.
And so they assigned me to the desktop computers to make sure they got into production and worked. And then I began to realize there was more fun than that. So I got into professional calculators. One of the stories I tell that's kind of interesting, I was taking into production at Texas Instruments the first programmable calculator. The same time I was taking a course at Southern Methodist on op amps. And so for the final, I called the professor and I said, can I use a calculator? He said, sure, calculator's fine. I said, well, this one's programmable. He said, whatever. There had never been a programmable calculator before this. And so I programmed all of the problems that were going to be on the test and sat in the class with the other 5 or 6 students, them listening to pss, 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 answer, pss, 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 answer. And so they weren't happy with me. I told them another product I was taking into production was a printer. And I could have brought the printer and just printed out the answers. And what I failed to tell them was, as you would expect, anytime you write a new piece of code, to debug it, you actually have to verify by hand that it does what it's supposed to do. So I had to do all of them by hand to verify that my code was good. I just didn't have to tell them that was the thing I had to do. It was more fun to watch them, the hair on the back of their heads go up a little bit when they heard me dorking with a calculator.
Yeah, work smarter, not harder.
Yeah. Well, came back on me several years later. There is I'm trying to remember the name of the show on public radio, public TV on technology, but they had a show on speed calculator technology, and since I had learned how to use a slide rule, they put me on camera with somebody else who had a calculator, and they'd give us a problem, and we'd each try to solve the problem, and I'd always get beat, seriously beat. And so uh, I remember several of my nephews saw that video, which I never told anybody that went on, and called to let me know that they had seen it and thought it was funny.
So how long were you in the calculator division?
About 10 years.
Hmm.
And the last set of products I worked on were the talking products,
Yeah.
which is the topic of our discussion.
Yeah.
Uh, but right after that, I moved from Dallas to Houston, from the calculator division to the semiconductor division, and took on the role of finding what I call new uses and new users of signal processing.
Mm.
And so I was always out looking at what were the crazy things going on within 10 miles of a university, led by a professor and his or her PhD students, encourage them, in many cases, lie through my teeth by saying, yeah, I'm certain you can do it. Go for it. And all they needed was the encouragement, and they actually made it happen. And so I got to be part of the 8 or 10 startups that we all kind of depend on now.
Can you talk about, the whole process of developing the TMS 5100? What were like the technical and non-technical challenges? Because I imagine starting to develop, or innovate and no one else thinks it's possible, and especially at a company, you likely get backlash and a lot of skepticism. So I would love to hear how that went.
Yeah, so let me tell you the startup of the Speak and Spell program, which is the first time I encountered a problem that the world thought was impossible. My boss, Paul Breedlove, he and I had just got off the task of taking the little professor into production. The little professor was not a calculator in the sense you put in the numbers and it answers it. It would give you a problem like 4 times 3. And you had so many seconds to enter the answer, 12 or whatever you did. And so same process, wrong, try again, wrong, try again. The answer is 12. Uh, and so we took that into production. And so Paul would, while we were doing that, was at home one night giving spelling words to his children so they could learn to spell and make a good grade on the test, and realized that we could do the same thing with spelling that we did with math. And the only problem is we needed to be able to do speech synthesis, which happened to be an impossible task at the time. And just so happens, and Paul uses the term serendipity. He and I had just finished up the little professor, and so we had nothing to do. A friend of mine, Larry Branningham, he and I would take on screwy new ideas and prove their feasibility inside the calculator division. He was a IC architect.
Mhm.
And then there was a brand new hire in the research center, Richard Wiggins, who understood vocoders. And so it just so happened that the 4 of us got together and started this idea of a speech learning aid. Now, either the good news or the bad news, we went to an educator, and the educator said, you can't do that because children don't learn to spell until after they read and write. And so that's 3rd grade, because we had asked him for a spelling list preschool to 3rd grade. And so he said, no, that doesn't work. Secondly, we teach spelling not by rote memory. And you're doing a product with rote memory. So no, you can't do that either. And so his answer was, no, don't do it. Oh, the 3rd thing he said was the only display you have is an all capitals keyboard or all capitals display. And he said, children learn to spell with lowercase, not uppercase. And so he said, don't do it. We took it to a set of parents. We took it to parents to have them look at it in focus groups. And to convey to them what it was, we had a pull string toy and a tape recorder.
Okay.
The conclusion from parents was it would be a poor reliable device that would break quickly because of pull string toy, and it would be a boring device because it would just say the words one at a time.
Hmm.
And so we got back from the educator, don't do it. We got back from the parents, don't do it. A third thing we had was Richard, as he came in, had some papers that had been written about speech synthesis by research people. And their conclusion was even with NMOS, which is a high performance silicon, you couldn't do it in real time. And we were going to do it with PMOS, not NMOS, because we needed the low power.
Yeah.
And so the inputs were all don't do it. From the research community, from the educators, and from the parents. What we chose to do was not let our management know that was their responses. But even management, we had two different methods of paying for a new project. There was the OST or the R&D budget.
Mm.
There was a wild hair, which said if it was a very low probability of success, you got wild hair money. Our management decided this idea, we called spelling bee at the time, was too risky even for the wild hair money. So we ended up, TI had another program called the IDEA program. And so we got an IDEA representative at TI to give us 25,000 bucks to go off and demonstrate the capability. Now, unfortunately, if you're familiar with TI's financial system, my cost center didn't get charged. It inadvertently got to another cost center. So we ended up doing it not for 25,000, for about $10,000. We demonstrated the capability. Now we almost lost the project at the demonstration because we had our senior VP come in and look at what we had done. And so we sat him down. At that time, the technology was you really effectively had a typewriter as the input to a computer.
Yeah.
And so we sat him down and started it up, and it said, spell cat. And so he was desperately going over the keyboard, the QWERTY keyboard, to try to find C-A-T, enter. And about that time, Richard made a terrible mistake. He said, yeah, that's level 1. Let's go to level 4. And so he hit level 4, and it said, spell ovoviviparous. And panic came on everybody's face, including the senior VP, because he couldn't spell, he couldn't find the letters on the keyboard, let us spell it. And so wrong, try again, wrong, try again, wrong, try again. Now spell onomatopoeia, which didn't do well for him either. He almost killed the program at that point. But the advantage we had, and I probably won't get in trouble. It's too late to get me in trouble for this. But what we found is when all of your management doesn't want it to succeed, they leave you alone because they don't want to have their name tied to it. Mm-hmm. So they did the most important thing they could have done. They left us alone to go do the project.
Well, it's quite a story. So I guess just to make sure our audience is aware, these words that the Speak and Spell says, they're not recorded, are they? They're generated. Is that correct?
They're generated with speech synthesis, yes.
Yes, wow.
It's a technology called linear predictive coding.
Okay. Could you just give a high level of that algorithm?
Sure.
Cool.
If you think about your vocal track, and if you think of those as, and we had 10 coefficients, so if you think of those 10 boxes, which I send the signal through, and each box processes it a different way.
Sure.
You replicated the vocal cords. Aha, I knew I'd get the right name. You would get the right information to create the sound you wanted. And so that was the technology we used. Sounds very straightforward, except, and what we did is we sat down, and in fact, I tell people, Larry was the IC architect, and we architected 3 new devices to go do this project.
Mm.
And Richard was the speech scientist, and so my job was to get them in the same room talking to each other and then get up and leave. And Richard tells a story I like, and that is once the research community worldwide realized that we had made this interesting breakthrough in speech technology, they would ask Richard, who did you have to go to for them to approve the algorithm? And he said, nobody. It was just us. And I got in trouble because the last thing you do once you get it past the lips in the electronic world is you need to roll off the signal so that if it's a 4 kilohertz signal bandwidth, you have to make sure nothing occurs after 4 kilohertz.
Mm.
And rather than do that electronically, I just bought a really cheap speaker for the product that had 2 poles or a significant roll off at 3.3 kilohertz. And the team in the research center thought I was an idiot because I was not doing it digitally until they realized I kind of knew what I was talking about and did it in analog.
Yeah.
And so that was a product. So that solved one problem, and that was the technology. There was a second problem, and that was this pronunciation of the words.
Mm.
And another person that came up on the team was a lady by the name of, come on. Let me just stop and say old age is a terrible thing. Alicia Helton.
Nice.
And Alicia was responsible for not only picking the vocabulary, but also making sure the words were pronounced correctly.
Mm.
Now, the vocabulary, the person who was the expert in teaching spelling finally concluded, he said, no, there are these 200 words, 250 words that you have to learn by rote memory. And they're the ones that increase the appearance of your IQ on IQ tests.
Mm.
Well, that's a big check mark.
Yeah.
And I just watched the video with Alicia a couple of days ago, and one of the questions I asked her was on the box, because she was also responsible for the box, did it say on the box that it increased the IQ of the student? She said, heaven's sake, no. Other issues we had was the state of the art of the technology at the time would only allow us to do a male voice. And at the time, most teachers of children that age were women.
Yeah.
But we couldn't do female voices. And it wasn't because a female voice had a problem. It was that our technology, for us to make it work, needed the low frequency of a male voice, not the high frequency of a female voice. When I've given presentations on this subject, and people would ask why I wouldn't do a female voice and a male voice, and I said, the simple explanation is there's not as much information in a female voice as there is in a male voice. And that's just the fact that the higher frequency you start at, if you have it banded, the less information you can use.
Yes.
And I would end that phrase by saying, and that's why women talk more.
To convey more information.
Yeah, to make up for the lack of information. Now, that not only didn't go well with the people I lectured to, that didn't go well with my wife and my 2 daughters when they heard me say it. But it was one of those things that you look at this and you say, well, what did you have to do? And I think the basis of what Larry Branningham and Rich Wiggins concluded was there were a host of compromises that had to be made to squeeze it into the capability of the silicon we had.
Yeah.
And you use the term TMS 5100. The device we did was the TMC 0280, which became the 5100 for the semiconductor world, and the 280 for the educational products world.
I see.
And so that was what we had to do, and it was a huge struggle. One of the side issues that came up was we needed a whole lot of memory to store the words, the spelling of the words and the speech. And to do that, 2 of the devices out of the 4 that we created were 128 kilobit ROMs. Well, at the time, the state of the art was 16 kilobits. And so part of this project was not only its speech synthesis capability, which nobody knew how to do, and a ROM design which was well ahead of the state of the art. And that's what made it as much fun as you could stand all night long worrying about. But that's how it worked out. One of the things, and by the way, let's see if I can go back and get this in a roadmap. We started the project in November of 1976. Oh, goodness, I have to go a long ways back. So November 1976, we started it. It was in production in August of 1978.
Wow.
And actually, we had demonstrations at the CES, the Consumer Electronics Show, in 1978 in June. And so roughly, what is that? Just about a year and a half for the whole project. That was an amazing turnaround with the things we had to do to make it happen.
What other, major projects or like highlights, or what you consider highlights, have there been in your career? And why do you think you've been successful pushing innovation forward?
When asked that by editors, the question would go something like this: what was the best problem you worked on? What's the best one? And I would say the next one. Because I enjoyed the get it started, get out of the way. And once again, I learned at TI and in my MBA that there's 3 kinds of people: starters, sustainers, and enders. And each is a different skill set. And if you tell a starter, like I was, to go run a program, I would screw it up. And if you told me to go in and kill a program, I'd really screw it up. And so there are 3 different functions that need to be done. And so I found my fun to go find that new idea and go talk to people and just encourage them to get started. I had all sorts of little tongue-in-cheek things to try to get their attention. Things like scratching your back. And the story I would tell goes like this: if I saw you walking down the street ahead of me and we were friends enough not to cause trouble, if I snuck up on you and just barely scratched your back, you would immediately begin to realize your back itched. And once I could get the back itching, then I could get you to scratch. And so I spent a lot of time out scratching backs.
what about your background made you able to be involved in so many different types of projects? Like you're involved in speech synthesis, you're involved in vision. Was it just the fundamental like DSP understanding?
Yeah, I was applying new technology to old problems,
I see.
and my joy being in chaos.
I hope I can enjoy chaos like you. So what would you say, to round it all out to, young aspiring engineers? Obviously like the speech landscape has changed a lot and there are tons of ways to spur. I mean, the whole technology landscape has changed a lot and there are many ways to spur it forward. So what would you like what's your advice or inspiration for our audience, which is young engineers?
It really comes down to be excited when you run into something that's impossible.
Mm.
The definition I have of impossible is a second definition, not the first one. Impossible normally means it cannot be done. To me, the definition of impossible is it hasn't been done yet. And so it is that vein of look for that opportunity. When I talk to PhD students, I find it interesting because the purpose of a PhD is to train you to find a new idea, exhaustively research it, advance it, and then report on it. And the number of PhD students I've talked to that thought, okay, now I've proven I can do this research area. I want to join your company and do the same thing, which is further the research on this idea. And I said, no, you don't understand. You got your PhD because you found something new that hadn't been done before. You researched it, advanced it, wrote on it. I want you to do it on something else new.
Yeah.
And so it's getting that in that comfort of doing something never been done before. I used to spend 2 days a year at MIT. I worked specifically with a professor by the name of Alan. So Alan Oppenheim, famous in the world of signal processing. But I was there to lecture, and we were walking from the hotel, which was about a half a mile from his office, to the office, and I was pulling my luggage behind me, and we were going over a brick sidewalk, and so I was hearing this, and
Yeah.
and so I brilliantly said to Alan, if they had laid the brick at a 45-degree angle, you wouldn't hear the noise. And he said, if you put a signal processor in each one of them, you could cancel the noise. And so we spent the rest of the time walking to his office talking about smart bricks. And for years, when he got a new set of PhD students, he would have brainstorming sessions of smart bricks.
Mhm.
Tell me what you guys do for a living.
Yeah, so Anthony is one of the co-founders here at Gridspace. I'm an engineer here. We develop speech and language technology specifically for call centers and anyone that needs a virtual agent or analytics for their calls. So one of our products goes by the name Grace, and she's a virtual voice assistant. Okay, so yeah, here's our website. These are all a bunch of different like bots we can try. So those are all like different Grace bots. So we can just try one. Does any one of them interest you?
Yeah, hotel front desk.
Okay.
Hi, you've reached the Hotel California front desk. My name is Grace. I'm a virtual front desk clerk. Are you a current guest at the Hotel California?
No, I'm not.
Are you looking to make a reservation, or do you have other questions I can answer?
I want to make a reservation, please.
Great. Thanks for your interest in Hotel California. Let me get some details from you. What day do you want to check in?
Can I check in tomorrow?
And what about checkout? What day?
What's tomorrow? Thursday? How about next Friday?
And what type of room do you want? 2 queen beds or a single king size bed? We also offer a few suites.
I'll take a single king.
Okay, you're all booked. We look forward to seeing you when you check in at the Hotel California.
Thanks. So that's quite a simple demo.
Yeah. Well, I seem to remember that the name of that hotel.
I haven't been there. If it's a real hotel, maybe we should change the name.
Isn't that the one that is in the song? Isn't there a song
Oh,
about that?
yeah. What is that the Red Hot Chili Peppers?
It's the song Hotel California, Natalie.
Oh, my bad.
It's by the Eagles.
But is it real?
Well, that's kind of the point of the song.
Not
Oh, no, I wouldn't change that. That just sets it up as a great demonstration.
It was a pleasure. All right. Well, that's it. Thank you so much. We really appreciate your time, and stay warm out there.
Oh, yeah. And off the ice.
Be careful. Take
Okay.
care.
Bye-bye.
We needed to cut time and you still included. Okay, hand for Jean Frey. Our next guest is Sandra Disner, who's also on the call today. She received her PhD in linguistics from UCLA in 1983. She was the senior linguist in the development of Mattel's Intellivision, which she'll talk about, which was the world's first talking video game. She developed the world's first talking video games at Mattel. She consulted for multiple different companies, one of which was Centigram, and she helped obtain a patent for abbreviation and acronym initialism expansion with Batilda Melchine. And she's consulted for multiple different companies as a linguist and for text-to-speech in the 80s all the way up to the 2000s. And now she's a linguistics professor at USC. So let's give her a hand.
I'm Sandy Ferrari Disner. Actually, I graduated from Wellesley College as an undergraduate, so I was given the opportunity to study at MIT. I took my entire senior year at MIT and enjoyed it enormously. Lived in McCormick Hall. Happy memories of those days, which were very formative for me. I'm currently a professor of linguistics and forensic linguistics in particular at University of Southern California. But before that time, actually for the majority of my career, I worked in speech technology. I was asked to talk about the history of speech technology, and I can't give you anything like the detail that Jean France gave you, so I will just tell you a little bit about 2 companies that I worked for that were pioneers in text-to-speech, and perhaps shed a little bit of light on the kind of Wild West that it was back then. In 1981, when I was working on my dissertation in linguistics at UCLA, I was approached by an acquaintance, formerly an engineer at the university, to take a job with his new employer, Mattel, the toy manufacturer, which had just created a new division called Mattel Electronics. The company needed a linguist for its new text-to-speech devices. And my skill as an acoustic phonetician and also my multilingual skills evidently appealed to them. My fellow graduate students were appalled at this. They said things like, "What? You're not going to look for an academic position? Or you're going to work for a toy company?" And finally, they'd say things like, "And what is a video game anyway?" Because they were completely unknown. We were the second in the market. I didn't convince any of my classmates of the worthiness of the project, but Mattel's first product, Intellivision, that's a mashup of intelligent and television, was one of the very first video games at all, and the very first talking video games. The first to offer a line. They weren't all talking, but they offered a special module and a special line of games that actually incorporated voice into the gameplay. Mattel realized that they could offer much more sophisticated and fast-moving gameplay if they presented the information, at least some of the information, auditorily, not just visually on the screen. Things like the number of advancing aliens and the number of seconds left and the time remaining to play. The product sold like hotcakes, earning hundreds of millions of dollars each year for the Mattel Corporation. The speech chips in the Intellivision line, actually the IntelliVoice line, were developed by General Instrument of Long Island, New York. The synthesizer unit in the special speech module was able to store numbers, a few keywords, and a beautiful baritone reading of Mattel Electronics presents. And then, of course, each individual cartridge would give its own name. But most of the speech there was just stored, so it didn't have to be stored over and over again in the cartridges. The individual cartridges contained the title and some dialogue for each game. These were recorded in Hollywood by well-known voice talents, including members of the popular satirical group known as Fire Sign Theater, who were just insane. They were so funny. They were such great improvisers. And being a toy company, Mattel insisted on fun and lively voices, some in extreme pitch registers, growly low and squeaky high, and with wild flights of intonation. Unfortunately, the game cartridges were minuscule by today's standards. Most of them were 8K cartridges, and the really flagship ones had all of 12K. 12K! And not much room was left over after the game had been loaded onto those cartridges for us to squeeze a little bit of speech in there. We did splurge on our first product, using almost all of our voice capacity on a phrase uttered by the onboard computer of a spacecraft tasked with shooting down aliens in outer space. The phrase was, "Hello, Commander. Computer reporting." But somebody got the bright idea of saying, why don't we make it a woman's voice? And why make it a sexy woman's voice? So we got an actress to say, "Hello, Commander, computer reporting," in this breathy, sexy way. It drove 14-year-old boys crazy, and it really boosted sales. The thought of a female onboard computer at your command was just more than people had ever seen before in a video game. The job of the staff linguists was to identify the representative portions of speech in the LPC output of our recordings and propagate them for as long as the steady state would allow us. So, of course, we favored calm, steady, low-pitched voices to be able to squeeze as much as we could onto the cartridge. But this was a source of constant conflict with the creative division of Mattel. They were a toy company. They wanted to cast ever more fun and lively voices. They had a growling Russian spy, and they had a southern, rural southerner saying, "B-17 bomber," which took up most of the cartridge. And then they also wanted the madcap laugh of Woody Woodpecker, as if we could do that. In my time at Mattel, I traveled the world to record voice talents in other languages. I worked on some truly fabulous video games, including several that remained on the list of best video games of all time for a decade, long after the demise of the company. And I had a lot of fun for a couple of years, but storm clouds were gathering. The $79 price tag, this was back in the 1980s, early 1980s, the $79 price tag of the IntelliVoice component alone suppressed the sale of all those IntelliVoice game cartridges. And on a larger scale, across the industry, a price war was developing as chips got cheaper and more people entered the market. Early computers were vying for us for market share. And let's face it, they offered more than just gameplay. They offered a computer. Price wasn't all that different. And then, of course, the famous E.T. the Extraterrestrial video game that was rushed to market by one of our competitors, Atari. They wanted to be sure to make it in time for Christmas 1982. was considered the worst video game ever made. And that soured the market on video games for the foreseeable future. Staff layoffs at Mattel began in the summer of 1983, and they continued until early 1984, when the Intellivision division, which had once produced half of all Mattel toys revenues, their operating income, I should say, was finally sold for a pittance. And in an interview about the video game industry, a vice president of Mattel was heard to say, well, there's no future in those things. I'd like to see what he thinks of the video game industry now, but he apparently thought that they were doomed in 1983. So I was out of a job. Let me shift to my second adventure in text-to-speech, not long thereafter. But I'll have to go back in time to tell you how this built up. Long before any of the Mattel shenanigans that I just told you about were taking place, back in 1971, there was a company called Telesensory Systems, founded by a group of Stanford engineers and scientists who developed a reading device for the blind. They called it Opticon. And it contained an optical character reader, which converted character images, the individual letters, into vibrations that could be read, as it were, with the fingertips of a blind person. It was much more versatile and certainly faster than waiting for Braille transcriptions to show up. You could, open your mail and read it instead of having somebody go to the trouble of transcribing it, weeks later. They did very well from 1971 to 1976, but in 1976, Ray Kurzweil, the real genius of the field in those early years, had entered the market with the groundbreaking Kurzweil reading machine, which output some rather rudimentary synthetic speech rather than vibrations. Brilliant idea. But the telesensory people, fearing this incursion into their market, went on a hunt right away for some front-end text-to-speech of their own, so that they weren't just asking people to read with their fingers, but to listen with their ears. The research ended right in your own backyard at MIT's Research Lab of Engineering, RLE, where Dennis Klatt had already created a software model of the vocal tract, and Jonathan Allen had crafted a set of letter-to-sound rules for English. The same system, the same software was prototyped for two very successful products in subsequent years, Klatt Talk and then Deck Talk. Even running on a newly designed Intel chip on the most advanced PDP computer of its day, actually an entire room full of computer power, MIT's early text-to-speech was very large and not very powerful. It took an hour for it to create just 1 minute of synthetic speech. So the telesensory engineers set about simplifying and refining the Klatt-Allen software to make it more efficient and thus more marketable. They eventually got it to work in real time, 1 minute for 1 minute of speech, with fewer computers involved. By late 1978, which was not all that long a development period, Telesensory's new OCR and text-to-speech device was being featured at trade shows. But the product was kind of buggy, and it still was rather slow, mainly due to the rudimentary camera still used by Telesensory for its optical character reader. At least that's what my friends the linguists said about it, why it didn't succeed. You had to draw the handset very slowly across the page so that one letter after the other could be read. Improved hardware brought some noticeable improvements. Texas Instruments had come out with a signal processing chip that could perform its calculations at a much higher speed. So Telesensory switched to TI chip with a Klatt model loaded onto it. Maybe it was one of Gene Francis' chips. I'll have to ask him. By 1972, Telesensory was able to perform real-time text-to-speech with just a single 8x10 board. Some of the truly standout personages in all these efforts, I should mention them, are Forrest Moser, a Berkeley physics professor who created the world's first integrated circuit speech synthesizer in the early 1970s. He was on contract to Telesensory. There were project managers Robert Savoy and Gabriel Groner, and engineer Jim Caldwell, whose meticulous programming for the TI chip hastened the product to market even earlier than expected. But problems remained. Telesensory's OCR never overcame its low resolution and slow speed, and the project became, frankly, too much for a small special needs company to handle. So in 1983, the company spun off its text-to-speech division into a new company called Speech Plus, funded in part by its main customers, Canon, which used Telesensory's chips in its own line of talking computers. We heard about talking calculators, talking calculators. We heard about those from Gene. It was kind of a fun but gimmicky product and fairly short-lived, at least the Canon version of it. And Westinghouse, that had planned to use Telesensory's text-to-speech in talking elevators all around the world. But it never progressed past a pilot program of putting text-to-speech into certain people mover devices in a few airports around the country. But once out on their own, Speech Plus concentrated on diversifying and improving its product line. It left behind the Allen letter-to-sound rules, and it tasked psycholinguist Jared Bernstein with formulating a much improved set of linguistic rules. The company began offering variable pitch and speaking rates, and its experimental testing found, to everybody's surprise, that a flat monotone setting was the best of the entire range at capturing customers' attention. So a number of corporate clients were attracted to Speech Plus's rather creepy robotic voice for marketing reasons, certainly not aesthetic reasons. Another early adopter of Speech Plus's TTS was the renowned physicist Stephen Hawking, who was afflicted with a severe neuromuscular disorder known as ALS, amyotrophic lateral sclerosis. And up until then, Hawking had been communicating by means of a fairly rudimentary letter and word selection device that had been crafted for him in his lab. But realizing that he needed something better as his fame grew, something that would allow him to speak aloud fluently at academic conferences and broadcast interviews, he visited Speech Plus right at our headquarters in Mountain View, California, and we gave him a board as a gift. In every successive year, the company tried to upgrade Hawking to a better, more natural-sounding product, but he wasn't interested, always replying that his audience had gotten used to that mid-1980s product, kind of robotic, kind of nasal, as his own voice. And he felt that they would be jarred by a sudden shift to some other, snappier voice, more baritone, mellifluous voice. So he stayed with it until the end of his days, 25 years later. I should just add on a personal note that not long before that time, not too long before Hawking's death, I attended one of his talks at UCLA with my husband, who was himself in the late stages of ALS. And it was a very emotional moment for me when I heard that long-abandoned speech product ring out in the UCLA auditorium. He never abandoned it. There was a brief flurry of enthusiasm when Speech Plus licensed its text-to-speech technology to IBM to be added to the entire line of IBM PCs. And I should point out that Dragon Systems did the same for its own speech-to-text device. But once our product had been adapted by IBM, it was never promoted much beyond that, and the license eventually lapsed. By the mid-1980s, the company slowly shifted its marketing to a new enhanced parametric synthesis system based on the digitized speech of a San Francisco radio announcer named Peter B. Collins, which was augmented by vector quantization. That much improved text-to-speech was considered a very, very high quality at the time and gained early adopters, such as one of the world's first GPS systems. They wanted it to read out street names to the driver. A major gaming company, Broderbund, the manufacturers of a highly successful translating device, the Instant Dict talking dictionary, an Italian car parts manufacturer. All kinds of people heard about us and licensed our product. We then contracted with universities and corporations overseas, including the Olivetti Corporation, the University of Madrid, the Fraunhofer Institute in Germany, to provide parametric text-to-speech for us in 4 additional languages: Spanish, Italian, French, and German. They'd all been working on the project, but we set new standards for them and they adopted it. All of these languages, all of these modules in 5 languages were painstakingly edited, tuned, and localized by Dr. Batsheva Melchin, herself a product of MIT's RLE, and her staff, a group that included me. One of my contributions, by the way, was a program for the correct pronunciation of acronyms on the page. So it would say MIT instead of MIT, and it would say PFLAG instead of FLAG. Much better than anything that's on the market today. I hear all kinds of clunky attempts by text-to-speech to read algorithms and abbreviations, and I keep saying, I solved that problem years ago. I mean, on it, and it's in the hands of Microsoft. Why aren't they digging it up? It's theirs. Anyway, that's my beef. But anyway, we had all these great customers, but sales flagged, or at least didn't grow. And in 1990, the Speech Plus Board of Directors sold the company and all its patents to Centigram Communications, a voicemail company that was interested in Speech Plus's interactive voice response capabilities. Always in search of new markets, but Sheva, representing Centigram, went to Redmond, Washington to pitch a novel idea to the technical staff of Microsoft. She said, "Would you like to buy our email reader?" Now you have to understand, back then, most people didn't have laptops. They had a very expensive computer on their desk at work, and they went home for the weekend, and that was that, except messages were coming on email, and they didn't want to schlep back into the office. But yaha, if you had text-to-speech, you could connect it to a phone line and make it an email reader and dial up and say, who's called me over the weekend? And if you had one of these products, you could read your email whenever you wanted. And Microsoft said, that's a great idea. They loved it. And so they licensed it. We were thrilled. Microsoft put Centigram's text-to-speech on its Windows chip that was adopted by many different companies. And for a while, Centigram was producing millions of chips annually in 5 languages, with hopes for an even broader market ahead. And then another cloud appeared on the horizon in the form of a company called Lernote and Houseby. Maybe you haven't heard of it. It's an interesting story. Lernote and Houseby Speech Products was a private speech technology company supported by the Belgian government as a way of creating jobs for its multilingual population there. There were certain disadvantaged parts of the country that was full of people that were multilingual speakers and very able to speak Dutch and French and even English. Cushioned by an extremely large government grant, Lernote and Houseby approached Microsoft, our customer, our main customer, our millions of chips customer, and made an irresistible offer. Accept our text-to-speech, free of charge, no strings attached. Microsoft accepted. Now, why wouldn't they? I mean, it was pretty crappy text-to-speech. Everybody hated how it sounded. It had this sort of nasal, whiny, somewhat accented English, and their other languages really never materialized to any great success. but it was free, and Microsoft wasn't all that invested in text-to-speech. It was just a feature, and if they can get it for free, why not? I mean, this was in the heyday of Microsoft. They were the 800-pound gorilla in the room. They could do whatever they wanted, but they obviously didn't want to give us the pittance that they were paying for our chips, and so they switched to Laird and Housby for free. And at that point, the Laird and Housby publicity office went into overdrive, and they started coming up with press releases that described the company as the sole purveyor of speech products to Microsoft Incorporated. This happened to coincide with Laird and Housby's initial public offering in 1995, which earlier had been predicted to yield pennies a share. And instead, with all this publicity about being the purveyor, they didn't mention purveyor for free, of speech products to Microsoft, the initial public offering opened at almost $12 a share. It was stunning. And it headed straight up from there. At its peak in the year 2000, Laird and Housby had a market capitalization of almost $10 billion. It used its revenues to buy up companies such as Dragon Systems, Dictaphone, Global Link, and Berkeley Speech, acquiring almost 400 software patents in the process. And along the way, it also acquired the text-to-speech division of Centigram. And almost immediately, our entire group was laid off, out of a job again. The party ended abruptly for Laird and Housby. Rumors of financial impropriety had been circulating for years, but had been largely brushed off by Wall Street. And the stock price kept climbing and climbing and climbing into the hundreds. And then the newly appointed CEO of Laird and Housby saw fit to visit his company's foreign subsidiaries. In Korea and in Singapore, he discovered fictitious transactions and improper accounting practices. Everybody in the industry was saying, how are they getting, hundreds of millions of dollars of orders? We're scrambling for $2 million here and $1 million there. But they were the darling of Wall Street, and they were the purveyor of speech products to Microsoft, so nobody asked too many questions until it came to the attention of the U.S. Securities and Exchange Commission. Shortly thereafter, Mr. Lernotte was arrested, Mr. Housby was arrested, the former CEO of the company, not the new one, because he seems to have been the one that alerted the SEC of these shenanigans. They were all arrested in what was considered one of the largest corporate scandals in American history. The company's stock plummeted immediately, and Housby filed for bankruptcy in October of 2001. Most of the company's patents were acquired by a company called Scansoft, which was, I think, spun off by Xerox some years earlier. And that company eventually merged with and adopted the name Nuance. And it has since been acquired by Microsoft.
I have a question. Our audience is mainly engineers. So I was wondering what experience as a linguist you bring, and if you could just elaborate to our audience the nuances of speech that you as a linguist are more attuned to, that just a signal processor or someone else like that might not be.
Well, first, the overall, there's two different ways we do things. Number one is if there are speech characteristics like a too gravelly voice or a lisping voice, we can call people's attention to those speech characteristics, and they can perhaps change some of the parameters globally to avoid them. And also things like rate and intonation. We were, of course, always looking, when I was working for Mattel, and all we could do was just pick out the representative glottal pulses that were then propagated. You could make better choices and make either a more compact or or more nuanced speech signal output. Of course, if you had somebody saying B17 bomb, or you had to pick, every other glottal pulse if you're going to track it correctly. So there were a lot of decisions to be made on the LPC from the LPC side of things. Also, we would be listening for pops and clicks and mispronounced sounds. If we were, after all, we weren't concatenating syllables like AT&T was doing, but we nevertheless had some juncture issues or some rule issues that did come up with unpleasant sounds, and so we'd identify those and try to find other ways around it. And then we did a lot of, for example, for the foreign language modules, we'd had to do a lot of localization because we had to have, there were different abbreviations, different acronyms. For example, in French and Italian, they don't mind having big clusters like CSELT and CNUCE. The Italian version of the federal research money came through something that was abbreviated as CNUCE. And in English, you might say, either spell it out or say CNUS, but they don't mind starting words with CNU, which doesn't happen in their ordinary words. And you just have to sort of recognize that and get the computer to pronounce it properly rather than just use the American standards for it. So we had all kinds of influence in all kinds of ways. We were certainly around when we were doing modeling of individual voices. We wanted to get the most. We wanted to look at accent and pitch and regional accent and the speaking voice, trying to get something that could be synthesized most effectively. Women's voices were more difficult because they just have higher pitches, and you'll sometimes miss a formant peak entirely. Of course, the Mattel people were always into having often a very stereotypically female voice that was much more difficult to synthesize. We were the ones that were saying we wanted to be understood. We don't care if it makes people smile. We just want to make it understood, and that's exactly the opposite of what the creative people wanted. I'll just tell you one story if I have time that sort of encapsulates it all. The first product I worked on was a shoot 'em up in space game called Space Spartans, and the aim, as I mentioned earlier, was to shoot aliens out of space.
Mattel Electronics presents Space Spartans.
And we wanted them to say aliens very softly and smoothly without a lot of flights of intonation so we could synthesize it well and not waste too much space. But of course, the creative people wanted to say aliens because it had to be matched with the numbers that were lodged on the main module. So 16 aliens. Well, we did the best we could, but when you have an expressive speaker saying aliens, it hit it really hard. It almost sounded like there was an H at the beginning of it. And of course, the "ya" in the middle of aliens, the speaker said it so forcefully that he probably raised his tongue up to the palate, and it sounded like a G, basically. So what sounded like aliens on the tape turned out, once we synthesized it on the EEPROM, to be heeligans. Heeligans. And my boss said, "What's that?" I said, "Oh my God, that was supposed to be aliens. Oh, we'll fix that. We'll schedule another recording." He said, "Sorry, too late. Christmas is around the corner. Do better next time." I was mortified. I said, "Oh my God, my first attempt at this, and I'm saying heeligans. Nobody's going to know what the hell that means." And I couldn't sleep for weeks. When it finally was put onto the market, and this was the days before blogs. People just had newsletters back then. They would issue the Mattel Electronics newsletter. I mean, the users would. These kids were saying, I shot down 45 hooligans yesterday. Well, I shot down 95 hooligans the week before. And I thought, my God, these people think that hooligans is something. They think that it's a special characteristic, some special race of space invaders. They have no idea that it's a crappy way of pronouncing aliens.
Under repair, tracking computer 1/3 down. Computer destroyed.
Aliens.
Just one last question. You said you had quite like some adventures in industry. How do you think that's shaped your like view of academia or your journey in academia since that point?
Well, first of all, it gives me a lot of cred, and it also gives me a way to teach people about the importance of intonation and the importance of context, not just in English, but in English societies, but also in French and in German, Italian. It's given me an appreciation for how very sensitive the public is to linguistic variation, how it can be used very entertainingly. I mean, it made a lot of people happy. I never had to pay a babysitter in all my life, because in all those early years, because people would volunteer to come over to my house, watch my kids, and play my video games, the new ones that hadn't been released. I actually thought I had to pay them because I'm a klutz. I couldn't get to the highest levels where I was supposed to be getting certain phrases added, but they were great. They would sit there play all afternoon and get to level 95, where I couldn't get past 2 or 3. But yes, it does basically show how linguistics isn't just in the academy, not just on paper, but in people's lives, and can make a difference.
That's awesome. I'm sure, when you were starting out as a linguist, did you ever think this was going to be your path, or were you always?
Oh, absolutely not. I was going to be a translator. My first job out of college was as a State Department translator, but that was no fun because all you did was translate other people's words. You couldn't improve it. You couldn't make it less ambiguous or less boring. You had to absolutely say whatever drivel this State Department functionary had said, and I said that's not for me. So
Yeah.
But besides, video games hadn't been invented then. People weren't using linguistics for fun.
Well, do you have questions for us? I know, I know you know about Gridspace and stuff, but
I know, I respect you enormously. You're doing great. You're doing great work. Sorry I couldn't come in today, but I've got classes before and after this.
yeah, no, it's been great to talk to you. Thank
Okay.
you. It's been a pleasure. Take care. Have a good day.
Bye.
Thank you, Sandra. She's on the call. Let's give her a hand so she can hear. She said she has class, but maybe we can catch her at a different time. That's it. We went a little over today. Thanks for people online and the Gridspacers and for joining us. That's it. Have a good weekend. Man, I'm sweaty. We needed to cut time and you still included. Back on. Thumbnail for you.